All right, so once again, just want to say good evening, everybody, and I am the lone presenter tonight for our 2022 Tropical Outlook. Joe Deli Carpini here. I'm the Science and Operations Officer. A number of people on vacation this week, and I think they got a good week to take off, so I'll be taking you through this webinar. Not a long presentation, but kind of goes through some of the details and some of the different factors that went into this year's Outlook. So first of all, who produces the Hurricane Outlook? It's actually many parts of NOAA. It's not just one particular office. So you can see here for the Atlantic, which is our outlook here in the East, it's the National Hurricane Center, but also a place called the Atlantic Oceanographic and Marine Laboratory, where they do a lot of bit of research. For the Central Pacific, it's a place called the Central Pacific Hurricane Center, which is co-located with the Forecast Office in Honolulu. For the western part of the Pacific, the Weather Forecast Office in Guam actually takes the lead, along with NESDIS, which is the Satellite Data Information Service. And for the South Pacific, WFO Pago Pago takes the lead. So, and involved with all of them are NCEP's central operations. That's where all the modeling is kind of run from, and NOAA Communications Office as well. So many people take part in producing these outlooks for different parts of the Atlantic and the Pacific. So to talk a little bit about both, there's kind of different schedules. So for here in the Atlantic, you can see our outlooks are issued twice. The season runs from 1st of June to November 30th. Sometimes there can be systems that form in May, but typically it's June through the end of November. The outlooks first come out in May, and then an updated outlook is issued in August, and I'll get to the reason why in a second. Notice for the Pacific, though, it's just one outlook issued per season for the Eastern and Central Pacific. The Eastern Pacific season runs a little bit earlier, starts on the 15th of May, but the Central Pacific season out toward Hawaii runs from the 1st of June to the end of November. Now, the reason there's only one outlook issued for the Pacific is notice when the peak of the activity occurs. It's pretty much straight throughout the season. There's not a pronounced peak, maybe a little bit here as we get into August and September. For the most part, it starts in May, it ramps up in July, and you're pretty much off to the races. But here in the Atlantic, note, here's the beginning of the season around June 1st. Really, we typically don't see much until about the 1st of August. And then, as you probably know, our peak is in about the first or second week of September, kind of around September 10th. So there's a chance to update that outlook on August 1st with new data before we get into the peak of the hurricane season. So that's why the Atlantic, typically we will see another outlook come out around the 1st of August, just to kind of update as to what's been going on. So let's take a look at this year's outlook. You're probably all familiar with it, and you can see here in the left-hand column, definitely an above normal season is predicted. The chance of an above normal season is 65%. Near normal is lower, only 25%, and below normal, 10%. So really the odds are favoring an above normal season, and I'll get into some of the reasons why here in a minute. Expecting a total of 14 to 21 named storms in all, and they give some wiggle room on each side. It's not just one number given. Number of hurricanes expected to be 6 to 10. And of those, 3 to 6 are expected to be major hurricanes. And an index that we look at called the accumulated cyclone energy, it takes into account the number of storms, the strength, things like that, expected to be above normal, running about 115 to 200%. So typically an above normal ACE, we call it, season, is greater than 130% of the median. So in the extremely active season will be more than 165%. So we're kind of in the range for both, having an above normal and maybe even an extremely active season here in the Atlantic. You can see last year's outlook is on the right, so it's a little bit above for the chance of above normal, but not too far off from last year's forecast. And the observed for last year, you can see we're at 65%, so 21 named storms, which is just on the outside of the range expected, in the range for the number of hurricanes and major hurricanes, as well as the ACE index, as you see there. So, face value, I'd say we're looking at a season similar to last year, maybe a little bit more active, but all in all, looks like the trends from last year are still in place for this year. So overall, little change from last year, which, as we know here, was fairly active with a number of tropical storms that impacted the area. So here's the overall hurricane season outlook for both the Atlantic and the Pacific. As I mentioned, the Atlantic, we've got pretty high odds of an above normal season. But notice the Pacific, both the Eastern Pacific and Central Pacific, odds favoring more of a below normal season, with only a 10% chance of an above normal season and a 30% chance of near normal. So why is that? We'll get into that a little bit. A lot has to do with the El Nino-La Nina cycle, which is a major player. But typically when the Atlantic is expected to have above normal activity, the Pacific, you can expect below normal and vice versa. So again, this is for overall activity. We're not mentioning anything about landfall because that's really not known until you're within 5 days or so or a week of when a storm actually develops, and we start to see how kind of the jet stream sets up. So again, above normal Atlantic, below normal for the Pacific. So let's put our outlook for this year in more of a historical perspective. And this shows the ACE, as I talked about, the Accumulated Cyclone Energy Index, the percent of the median. So for those of you who've been around a while, we certainly know we had a high activity area, or if you're maybe a historian of tropical cyclones here in New England, definitely had a high activity area in the 50s and 60s. And you can see many of those seasons here with above kind of the average here in the red of the median. Definitely in the 60s, there were some active years as we had some pretty famous storms back then. Then in the 70s into the mid 90s, went into a low activity era. So notice most of the seasons had a low energy index, well below the average. A couple of exceptions here, the late 70s and about 1988, which I believe was Hugo was located in that. But now since 1995, we're back in another high activity era. And you can see there were many, many years above the average since about 1995. And our May outlook for this year kind of puts us in the same ballpark. Again, maybe a little bit above last year, but maybe similar to more 2020, anywhere from 115 to 200% above the median. So we're certainly in a high activity era. There's more research kind of going into this ACE index, how it works. But like many other things in weather and climate, it's cyclical. So we go through high activity periods, low activity periods. When one switches to the other, it's a little hard to say. The research is still fairly new, but we're seeing that these high activity eras certainly favor, obviously, a lot more tropical cyclone activity. So here's a forecast summary. Obviously, we use the weather models and climate models coming up with these forecasts. So these are some of the ones that are used here on the left. I won't go through all of them, but some of them might look familiar. The European, the UK Met, the CFS, which is, think about the GFS, but run on a kind of a longer time frame. So it's a climate forecast system. And these are some of the models that are used to come up with the outlook. And you can see each has its number of named storms, and all of them are fairly high number, and the kind of the average in the parentheses there. The number of hurricanes, major hurricanes, and the ACE index. So you can see the guidance mean here in purple, and then the NOAA outlook in red. It's not taken verbatim, but typically will be pretty close. Using kind of this ensemble approach, irons out some of the the poor performers and incorporates a lot of the good performing models. So you can see pretty much, the best forecast in May before things really get cooking is to go with that close to that guidance mean, and certainly that's where our forecast is here. Maybe nudged a little bit above when it comes to the ACE index based on, the recent activity, but overall right in line with the guidance mean for, a number of these global models that specialize kind of in tropical activity, including forecasting the El Nino-La Nina cycle. So the one interesting thing that was brought up to us is the number of hurricane landfalls. And again, you can't predict exact landfalls based on the number of storms you have per year, but it's interesting to note during these high activity eras, again, we've been in one since 1995, we typically see the largest increase in hurricane landfalls along the Atlantic coast. And you can see that here. There's actually a 99% increase during these highly active years. As opposed to the Gulf Coast, it's pretty much an even split. It's a wash, whether they see more landfalls or not. But definitely along the Atlantic coast, there's a signal. And overall, there's about a 49% increase. So that means, as mentioned here below, the U.S. sees almost a doubling of seasons with multiple landfalling hurricanes. They occur about every other year compared to about every fourth year. So definitely something just to keep in mind here on the East Coast, anywhere from the Carolinas, Florida, up into New England, that there's certainly a greater chance of hurricane landfalls in these higher activity eras. Okay, so what factors are contributing here to the forecast of the above normal activity. It's not, we're not just going to take the models and run with them, but, what's going in? There's certainly a number of factors here at play. Well, the process behind the outlooks takes a lot of factors, but there are three main ones that go into account here for the Atlantic hurricane season. One is called the Atlantic multi-decadal oscillation, and this is a 25 to 40 year signal that it varies. It reflects fluctuations in Atlantic sea surface temperatures and the West African what's called monsoon. Now, a monsoon is not one weather event. It's actually a weather pattern. And we see a rainy season. Think about the desert Southwest. Think about West Africa. Think about India, where they have weeks of shower and thunderstorm activity. That's their wet season. And, the desert Southwest certainly sees that as well. So that's what we mean by a monsoon. It's a weather pattern, and it's a wet weather pattern. So this is an oscillation of that off the coast of West Africa. And those systems are what eventually can grow into tropical depressions, tropical storms, and eventually hurricanes. Now, I think the one we're most all familiar with is El Nino and La Nina. That's certainly a big player in our forecasts of hurricane activity in both the Atlantic and Pacific. And this reflects year-to-year changes in kind of the tropical Pacific Ocean temperatures, and we'll show that in a minute. I think many of you are familiar with that. We look at that for winter weather, too, the El Nino-La Nina cycle. But it also plays a role in tropical activity. And of course, year-to-year fluctuations in Atlantic sea surface temperatures. Hurricanes like warm water, 80 degrees or higher, gives a lot of energy. So if we have above normal sea surface temperatures here in the Atlantic, even up here into the Northeast, that means there's more energy for these storms to survive, for one thing. They won't weaken or they won't become extratropical, as you'll learn about in that webinar next month. But it's certainly, these are the main kind of three players. And the models used that kind of show, some of them are statistical, which takes into past kind of performance. Some of them are dynamical, taking into the processes of the atmosphere. And some are kind of a combination of both, a hybrid approach. So that's kind of the easy way of kind of explaining how it works. It's definitely a complicated process that's done by the NOAA folks. So all right, let's dig in a little bit here. The ENSO status, what's going on? Well, during the last couple of months, and we're going kind of back to April and May, still seeing cooler than normal ocean temperatures across the equatorial, central, and eastern Pacific. And that's where we look for El Nino and La Nina. So these cooler than normal ocean temperatures prevail near the surface. And what we're seeing here, this is kind of a cross section. So you're looking kind of east to west across the Pacific. This will be off the coast of South America. But you're also looking down in depth. So how deep is this cold water? You can see it's not too deep here off the coast of South America. And notice there's actually some warming here in the western Pacific, but it remains at deeper water. So up at the surface, it's actually more toward the near normal. And what that simply means is, the warm air or the warmer water is not really winning out. It's being suppressed down at greater depth. So we're not going to expect to see this La Nina really abruptly end anytime soon. That's kind of the upshot of all this. And so as a result, the Climate Prediction Center, looking at the forecast, this was back in May, which is our latest forecasts, showing, a 58% chance that La Nina is going to persist through August, September, and October, which is the peak of our hurricane season. You can see the different probabilities. Certainly favors La Nina here in blue, to a lesser degree neutral, but really no chance of seeing, El Nino returning for this year. And it's La Nina that really favors the increased tropical storm or hurricane activity in the Atlantic and a decreased potential in the eastern Pacific. On the opposite side of the coin, when we're in El Nino patterns, the Atlantic does not see very much activity, but the Pacific sees a lot more activity because there's warmer water, so more energy. So keep in mind right now in the Pacific, there's cooler than normal water temperatures for the most part where these storms develop. So it's less favorable for tropical storms and hurricanes to develop in the eastern Pacific. So the ENSO status, this is kind of an interesting graph. It kind of shows what's called there's a double dip sometimes in La Nina winters. And this shows, kind of the history of the years when we've had this kind of double dip. In other words, there's a La Nina that peaks in the winter. It may relax a little bit in the spring, but by the next winter, it kind of occurs again. So we're in that kind of pattern right now. So the black line shows us where we are. So this was last year of 2021. You can see we had a dip. And this is a La Nina. It relaxed a bit during the year. It was still negative, but slightly negative. And then last winter dipped down again. So, when we look at past history, it's like, what would happen? Is this really going to go even further down? Is it going to, come back up? Well, really the odds kind of favor it staying somewhere, near in a weak La Nina. It's possible that it could shoot up, but it's certainly not on that curve right now. It's kind of on this blue curve, matching that a little bit better. So the odds are favoring that we'll stay in this at least a week La Nina into the winter of 2022 to 2023. If we were going to lose the La Nina, go to the opposite El Nino, we probably would have seen that start to happen already, as you can see here by the red curve. So just an interesting thing that was brought up to us by some of the climate prediction folks, that we're most likely to see another dip this winter. So another La Nina winter appears to be likely here for North America. And just to show you kind of some of the forecasts, some of the sea surface temperature forecasts, what's going on, we're in the black line here. All of the models show, somewhat into at least a weak La Nina or a little more moderate. You can see there's good variability. The forecast is this dashed line here, which kind of splits in the middle, which makes sense at this point. But this is the forecast for ocean temperatures just off the coast of South America. This is called the Nino 3.4 region, which is where we measure. So again, the conditions favor at least a weak to maybe moderate. This is more of a moderate La Nina between -1 and -2, persisting into December at this point for next winter. So we'll see. And just to show the recent sea surface temperatures again, what's going on, you've got your La Nina here in the Pacific, but notice the Atlantic, and this was back in April, so this was kind of the early look that went into the outlook for May. Notice there's a mix of kind of above and below average temperatures, and this green box is called our main development region. This can be anywhere off the African coast to the kind of the Caribbean. As we get into more July and August, you might see some more systems form over the Bahamas, a little closer to home. But notice even in April, pretty good departures already from average. So we're seeing warmer than normal sea surface temperatures, and that's even continuing now through most of the Atlantic, which is a sign that we could see some, it's certainly favorable for more activity. And eventually this will trend warmer as well. Again, this was back in April, a little bit early. But again, over the whole box, it's near average or even slightly above average. So that's a favorable factor for more activity. And the predictions as we go into August, September, and October, note the La Nina continues here over the Pacific. But notice the temps in the main development regions start to warm a little bit more. Now we've got more positive, what's called anomalies. You see more of the slightly yellow shading here, and certainly in more of the Atlantic, it's above normal, well above normal here as we get off the Canadian Maritimes. So definitely a good source of energy for potential cyclones, tropical cyclones, if they develop in the area. And you can see, this was the CFS, the Climate Forecast System, even the North American, what's called the Multi-Model Ensemble, showing above average temperatures, or at least near normal in this main development region. So again, favorable factors as we head into the tropical season. And not to be outdone, we also look at some of the wind anomalies. So what's the, essentially the shear, is it going to rip systems apart? If we have strong winds in this main development region, it's hard to organize these thunderstorms into, tropical systems. So you can see here, not a lot of, of strength here. Certainly, there's a little bit more of a signal here, more westerly winds. And what does that mean? It means weaker tropical easterly winds, so similar to last year. So again, favorable for some more activity in this development region. And as I talked about the West African monsoon, this is showing, the green is kind of more favorable for more activity here. So more tropical waves coming off the coast, a better chance that some of them could develop into tropical storms and hurricanes. So we will see how that goes. So to summarize our expected conditions here in the Atlantic, the ongoing high activity era conditions favor more activity. This includes the La Nina and the above average sea surface temperatures. Again, in this main development region that I put in the yellow box, near or weaker than average vertical wind shear, that's good. That means that we can develop bigger updrafts, more organized thunderstorms, and favors activity. That means good if you'd like to see more hurricanes. And of course, weaker easterly trade winds and vertical wind shear also favors that, along with a stronger and wetter African monsoon. So, Overall, again, above average sea surface temperatures, La Nina, and weaker than average vertical wind shear. Those are all favorable conditions as we get going here more into the tropical season. Again, I think we'll start to see things really begin to develop August and especially September. Similar to last year, not much happened, a little bit happened early on, but really got going in the August-September timeframe. So that's really what we want to watch. So in summary, for the Atlantic, an above normal season is most likely with 14 to 21 named storms, 6 to 10 of which are expected to become hurricanes, and of those, 3 to 6 are expected to be major hurricanes, category 3, 4, or 5. And for the Eastern Pacific, kind of the opposite side of the coin, below normal season most likely, 10 to 17 named storms, 4 to 8 hurricanes, and just 0 to 3 major hurricanes. But just remember, as we always tell you, it always only takes one. So even a low active year, I will go back to 1992. Hurricane Andrew struck then. It only takes one. So always go to weather.gov.safety/hurricane for your preparedness information. And just to wrap up, I want to talk a little bit about, understanding some of that information. This is always a good refresher. Again, we have a very weather savvy audience, so I'm sure many of you are familiar with this, but just to reiterate, always we start off, with our big picture, our tropical weather outlook, and they're available for 2 and 5 days, color-coded by increasing potential. So the low chance, less than 30%, is yellow. The medium chance of 30 to 50% is orange. And the highest chance of greater than 50% is in red sometime over the next 5 days. That's a great place to start to kind of find out what's going on. And I will show you that in the weather briefing tonight. So when we get to the cone, this is where we have a lot of confusion. So the forecast cone indicates the probable track of a system. So I know we always get hung up on, where's the center of the storm, but keep in mind at these different time ranges, the width of the cone represents historical forecast errors. So obviously errors are small in the, the first couple of days, but they get bigger and bigger as you get out to 3 and 5 days. So, the storm here is shown kind of near Binghamton, New York at this last forecast point. It really could be anywhere from almost Cleveland to Worcester, or up into Canada or down into the mid-Atlantic. So keep in mind, it can be anywhere within this cone, but at a third of the time, it can also be just outside the cone. So really, the thing I want you to key on is, kind of keep an eye on where it's going, but you can always have potential impacts well outside of this cone. That's kind of the most important thing. Don't always focus on the exact track. There's going to be some wiggle room here, and some of the other forecast products that we provide can certainly help with things like flooding, rainfall potential, high wind potential, tornadoes, and storm surge. So those are things you really want to kind of pay attention to. And one of the things that we really find, most people like are the arrival times of tropical storm force winds. And why do we use that? That's really when you need to have your preparations done, the arrival of tropical storm force winds. That's when it's really no longer safe to kind of be outside and preparing. So there's 2 that you can use. One is called the earliest reasonable arrival. That's kind of what's the earliest time I could get tropical storm force winds. You can see here it's Tuesday 8 a.m. to maybe 8 p.m. kind of over our region. And then there's the most likely, which obviously is the most likely time. It's usually about 6 to 12 hours after the earliest reasonable arrival time. But for safety and keeping that kind of safety margin intact, we always recommend going with the earliest reasonable time. It's probably going to be a little bit too early, but you'll have everything safely prepared for by then. So kind of go with that, but realize that the most likely is obviously when we really expect tropical storm force winds to arrive. So watches and warnings. Again, there can be a little bit of confusion with this. It doesn't mean everywhere within the watch or warning area is going to experience these conditions. It means conditions somewhere within the watch warning area will experience either hurricane or tropical storm conditions. And the watches, again, are issued about 48 hours in advance of hurricane or tropical storm force winds. And the warnings are issued about 36 hours in advance. And that, we can stretch that out sometimes, say if it's a holiday weekend. Labor Day weekend, for example, we might put the warnings out a little bit sooner than that, just so people are prepared. But again, it doesn't mean everywhere in this yellow area is going to experience the conditions. It means somewhere. It could be New Jersey. It could be Long Island. It could be Cape Cod. It could be all of it or a very small section. So just something to keep in mind. Doesn't mean the forecast is a bust. These are issued, again, with safety in mind, getting people to prepare who are most at risk for hurricane or tropical storm force conditions. And where do you find all the information? Very easy. hurricanes.gov. We've got all the outlooks there from the National Hurricane Center, and you can go back on YouTube. And once I upload it, and you can see all about hurricane preparedness in case you were unable to join. So with that, that is our webinar for tonight. I'm going to pause here. I'm sure we've got some questions, and then we'll get on to our weather briefing. So let me go through. Let's see. Go through a couple of questions. If you've got any, go throw them in the chat. Let's see what's happening. So from Ethan, let's see. A question on the activity slide. So the historical perspective slide divides activity into 3 periods: high, low, and then high again. So the historical observed periods, the first 2, last about 20 years. Since then, the period started in 1995. Does that mean we'll go back into a low period within a few years? Yeah, good question, Ethan. We really don't know. We're only going back to the 50s, so that's not, from a climate sense, it's not a lot of data, 70 years. So it's tough to say. It's certainly possible, but I always say, past performance doesn't indicate future trends either. So it's certainly possible. We'll just have to kind of wait and see how things go. But, we've kind of been wondering, are we kind of at the end of the era now? And we've been saying that for a few years, and it hasn't happened yet. So either we're in kind of an era that's going to last a lot longer than 20 years, or it's kind of on its way down. So we'll just have to kind of wait and see as to what happened. But good observation there. And another question, is cold water or land interaction more detrimental for tropical cyclones? Can they still strengthen in cold water? No, that isn't good. So the things that hurricanes really don't like is colder water, so less than 80 degrees Fahrenheit. Interaction with land, so making landfall is a bad thing, or increasing shear, meaning change of wind direction or wind speed with height. Those kind of rip the circulation apart. So yeah, at that point, if we have cold water, or and you'll see this, Ethan, in our extratropical webinar, that's really what happens a lot of times. The sea surface temperatures up here are less than 80 degrees. It starts to become what's called a cold core system, like a nor'easter. And we'll get into a lot more of that in our webinar next month. But yeah, it's definitely detrimental for that. Question from Kevin. Do the meteorologists at the Hurricane Center for the Atlantic Basin Outlook in May take statistical average of tropical cyclone frequency and come up with a prediction of number of storms and whether the season will be above or below? They do a little bit, but like I mentioned, Kevin, there's a lot of different other factors at play. That's certainly one part of the equation. It's kind of a smaller part. They look more at the larger scale factors, again, that El Nino, La Nina, sea surface temperatures, wind shear in the main development region, things like that. But yeah, that is to some degree a part of the formula. Let's see, another question on the ENSO probability slide. What do the different bars represent? I believe we're looking at, that was just showing kind of the different model forecasts, I think. So looking at different probabilities of above average and below. So yeah, from months past, there were some neutral and some in La Nina. They're kind of taking the average of all of those, Ethan, if that makes sense. So we're just kind of looking at the different model forecasts for each. And a question, what upper level patterns are favorable for bringing tropical cyclones to our area? Obviously, it's actually similar to winter storms. So think about, you want a big trough in the east, maybe somewhere over the Great Lakes, and you want that flow to come right up the coast. So if you're looking at the 500 millibar level, you want that flow to come up from the Carolinas to kind of steer that system up here. Or you can have a big high pressure system over, say, the Canadian Maritimes. They're going to block it, force it inland. That's what happened with Henri last year. So you want some sort of trough in the east. It helps if you have a blocking ridge or high pressure up over the Maritimes or the Western Atlantic. That kind of forces the system in here to New England. So those are the things we look at a week or almost sometimes 2 weeks out, just to kind of get a general sense of where a storm might track. So from John, where do hurricanes that hit New England typically form? And how does this correlate with this year's seawater temperatures? So there's a couple of ways. One are the long-lived ones off the coast of Africa. Those are the big buzzsaws that take a few days to cross the Atlantic, and sometimes they can come up here. Most often, though, and this is our rule that we've mentioned before, look in the Bahamas. So a lot of times as we get later into the season, think August, September, we can see tropical storms and hurricanes form very quickly around the Bahamas, where the sea surface temperatures are very warm. And those are dangerous because they can be up here in a day or two once they get caught up in the jet stream. So I always look early in the season, kind of over the open Atlantic. But as we get more into August and especially September, start looking more toward the Caribbean, Bahamas especially. As we say, anything with the name of the Bahamas is our business here in New England. You want to pay attention because it can be certainly an offshore pass, but it can also be a direct hit or west of us, which brings a lot of wind to the area. So again, keep your eye on the Bahamas as we get a little bit later into the season. That's typically where we start to see them form as we get later into the season. But also don't take your eyes off the African continent either, because the longer-lived buzzsaw storms can easily form there. And a question on the cone from Ethan. Let's see, with the forecast graphics, you mentioned the cone indicates the most probable areas where the eye could be. However, longitudinally, meaning longitude, should they also be interpreted for latitude as well? Yes. So the forecast points, Ethan, are given in latitude and longitude, and that's how it's plotted. And then it's plotted where you see the center, and then the cone is drawn around it with historical errors. So yes, those are lat-long positions throughout the next few days for the tropical cyclone. Question from John, is climate change factored into hurricane forecasts? Indirectly, yes. So we use the climate models, which actually factor climate change, things like sea surface temperature trends in particular. But, other effects of that, winds aloft are taken into account. So, yeah, to some degree they are. So the climate forecast models, do a decent job with that. So a lot of the things I talked about, in particular sea surface temperature, are included into those hurricane forecasts. Good question. From John, I was waiting for this question. Okay, he's read the Sahara dust over the Atlantic and Caribbean can inhibit tropical system development. Is there a time of year when the dust is most likely to be present? Yes, and in fact, that's happening now. I was trying to find a satellite picture to show you, but there was really nothing that showed it very well. But the reason we're not seeing much right now, there's Saharan dust over the Atlantic, and that suppresses activity. Think that it suppresses kind of the convection. To some degree, it kind of cools things. I'll put cool in quotes. So we don't think about thunderstorms trying to develop. If you're cooling things just a little bit, they can't really form and organize. So yeah, that works in cycles. We tend to see it, at least some point over the tropical season. I haven't seen any latest forecasts of it myself, just because I haven't had a chance to look at it. But typically that will start to wane, and then we will see a little bit more probably activity get going again a little bit later in the season. But yeah, the Saharan dust is one thing that can be a big, really throw a monkey wrench into some of these forecasts. So we'll have to kind of wait and see. Let's see, from Chaz, the water is getting warmer every year. He's seen storms develop north of the Carolinas when the water is warm enough. Is that becoming more likely? Yeah, Chaz, that's one of our main development regions, even off the Carolinas or, off the mid-Atlantic. Depends on the sea surface temperatures, depends on kind of how the jet stream is configured, but sometimes you can see a system develop very quickly in those areas as well. So all goes back, like you said, to sea surface temperature. We're in a pattern now of just having a few years of warmer than normal temperatures. That's certainly favorable. So another area to watch as well. We always say Bahamas, but don't rule out even the Carolinas, mid-Atlantic. Sometimes a storm can develop there as well. Let's see, next question. Keep them coming. Do tropical cyclones that live longer have the potential to pack a greater punch, in that if you compare a cyclone that formed off the Atlantic versus one that formed off the coast, they both had the same intensity? Would the one that formed off Africa keep its strength for longer? Yeah, that's possible. Typically, Ethan, the ones that form off of Africa are much better organized because, heck, they're around longer. They're feeding off the warmer water. There's usually very little wind shear, so there's a lot of energy, a lot of ocean for them to cross, days, 3 to 5 days or more before they even get to the Caribbean islands. So that has the chance to pack a lot more punch than one that forms, say, off over the Bahamas. Not to say the Bahamas, you couldn't have one develop quickly, but our big storms. So think about our Andrews, our hurricanes of 38, storms like that. The big ones typically are the ones that come off the west coast of Africa and spend days coming across the ocean. So yeah, that's a good observation there. Let's see, does wind shear decrease later in the season? And can wind shear be stronger or weaker with multi-decadal patterns? It kind of varies. So as we look at the jet stream pattern, we can kind of see when wind shear is going to increase or decrease, or if a storm is currently in an area of greater wind shear, if it's going to go into area of less wind shear. That happens quite a bit. So a storm that might be near Puerto Rico could be dealing with some land interaction. Maybe a little bit of shear is present. But then maybe there's a high pressure ridge over the Gulf of Mexico, and that's an area of very low shear. So the forecasters know, okay, it's getting beaten up a little bit right now, but in another day or two, it's going to move into a more favorable environment, and we're going to forecast strengthening maybe to a hurricane. So that's kind of how it works. There's no particular pattern of wind shear. Typically it's greater earlier. Think spring and early summer. The jet stream is still a little bit stronger than it is later in the summer, especially in the tropics. But it really just depends on the overall kind of upper level pattern that we look at. Think about 500 millibars, 18,000 feet, or 200 to 300 millibars, closer to 40,000 feet. All right. So I think that will do it for our questions for now.